Welcome back, everybody. This is our first class in NEET previous year questions for chapter Current Electricity. Before this video, we have made several videos for NEET previous years, and all of those videos can be found on our YouTube channels in playlist section. We have also started similar series for JEE mains, so if some of your friends are preparing for JEE mains, then you can suggest them those videos and that playlist also. And if you find these videos useful, then do press the like button, share them, and subscribe to our channel. It helps a lot when you share and subscribe. Also, if you want to support us financially, then you can scan any of these QR codes in front of your screen and can donate us with whatever amount you want. Any donation, however small, will be highly appreciated and it keep us motivating to bring these videos on regular basis. Now with this, let's start today's video. Now this is the first question. In the in electrical circuit, voltage is measured as V. So value of V is given to us. V is 200 plus minus 4 ohms. And we know that when we write some value in this, then it is V mean, means value, mean value plus minus error. So here we have actual value, here we have mean value, and here we have error. Let me write in a proper way. Here we have, you can say not actual, possible value. Possible value is equal to mean plus minus error. This is the form in which above expression for potential is written. Now value of I or current is also mentioned, that is 20 plus minus 0.2 ampere. Here I mean value for I is 20 and error is 0.2. So we have to find out the value of resistance, and we know that V is equal to IR from the Ohm's law, and using this R will be V by I. Now what is V? Here, if you can see in the answer, we will have two values for R. One is mean value and then second is the error value. So first we will find mean value. So R mean will be given by V mean by I mean. V mean is 200 and mean value of I is 20. So mean value of R is 10. Now coming to the error part. Now for error, we have to use error analysis. Only then we can solve it. And as per error analysis, using this expression, delta R by R will be delta V by V plus delta I by I, because we have to always find maximum possible error. So that's why it will be in positive form. And from this, here R, V and I are the mean values. So delta R will be R times delta V by V plus delta I by I. R is, mean value of R is 10. Now error in potential, that is 4 by mean value 200 plus 0.2 by 20. Now 0.2 by 20 can be written as 2 by 200. So this will give us 4 plus 2, 6 by 200, and 6 by 20, 3 by 10 is equal to 0.3. So our value of R, final value of R is mean value, that is 10, plus minus its error, that is 0.3. So option B will be the right answer. Moving to the next one. Two solid conductors are made of material and of same material, Same material means their resistivity of rho is same. Rho is same. Okay, wait a minute. Rho is same and have same length, same resistance. One of them is circular cross-section area A1 and other has square cross-section area A2. The ratio we have to find. So for them, rho is same, resistance is same, and we can say length is same. One of them is cross-sectional and another one has a square area. So one of them will look like something this, which has cross-sectional areas. It will be something look like this. And now with square cross-section, it will look like this, like a bar. Something like this. It will look like a bar. Now its area is A2 and its area is A1. We have to find ratio of these areas. So for this, what we do? So what we will do here, we will first write the formula for resistance, and we know that resistance is rho times L by A. Now here when we have a circular cross section, so we will denote it as C, and another we have square cross section, so we will denote as small s. So resistance of circular cross section is equal to resistance of square cross section. So it will be R rho times length of circular by area of circular into rho times length of square by area of square. And we know that rho is same for both of these. Length is also same. So from this we can say AC is equal to AS and their ratio will be 1:1 or 1. Option B will be the right answer. Next question. The resistance of a wire is R ohm. It is melted and stretched to n times of its original length. Its new resistance will be. So we know if you have solved these type of numericals that if volume is constant, if volume is constant and you change length of a wire, volume is constant and length of wire is changed n times. If its original resistance was R node, then new resistance is equal to n square times R node. So its answer will be option C, and we will solve it proper mathematically also. So let's do that. As volume is constant, so we know, let's suppose L node was initial length and A node was initial area, and V is equal to L node times A node. Now suppose new length L dash is n times of the original, so it will be n times L node. So from this what we can say, as volume is constant, so initial volume is equal to final volume. Initial volume is L node times A node, and final volume will be final length into final area. Final length is n times L node and final area will be, we can say, suppose it is A. So from this L node get cancelled and we have final area is equal to old area A node by n. Now we can find value of resistance. Suppose old resistance is R node and it should be equal to rho times L node by A node. New resistance is R, so it will be rho into new length by new area. New length is N times L node and new area is A node by N. So this will N go on up and we will be left with rho times N into N square L node by A node, and this value is equal to old resistance. So N square times R node. Option C will be the right answer. Moving to the next one. Wire of resistance 4 ohm stretched twice of its original length. Resistance of the stretch wire, as we just solved the previous question. Here uh, it length increases to twice, means here N is equal to 2. So resistance will become N square times old resistance. So 2 square times 4, it will be 16 ohm. Option D. Next one. A wire of certain material is stretched slowly by 10% and new resistance and specific resistance becomes respectively. Now, here we have to find out changes in resistance and specific resistance. So we know that rho is material property. Rho is property of material. If material does not change, specific resistance or rho does not change. So it will stay the same. So option A get cancelled because here it is mentioned that it is changing, and option D is also get cancelled. And as we change dimensions of a material, its resistance will change. So out of B and C, B seems to be a possible option, and let's find out that it how which of them is right. So material is stretched slowly by 10%. So we can say if its in original length was L or L node, then its new length L is equal to 10% more. So it is 1 point, we can say 110 by 100 of L node. How we got this value? This will be 1 plus 10 by 100 into L node. So this is our new length. And we know that as volume stays constant, then radius will also change. So what we can do, we can do error analysis here and then can find change in resistance, or we can just write like this, that length is equal to 1.1 times of L node, and from this we know we will get N is equal to 1.1. And as in the previous question, that if length of a wire is increased by N times, resistance becomes N square times. So here length of a wire is increased 1.1 times. So its resistance will become 1.1 square times of the old resistance. So we can say R node, and square of 1.1 will be 1.21 times R node. So new resistance will be 1.21 times. Option B will be the right answer. We can also solve this type of question using error analysis, and let's do that using error analysis. So we know that R is equal to rho L by A, and we can now change in R means error percent relative error in R will be equal to, as rho is material property, there will be no error in this, so it will be delta L by L plus delta A by A. This will be the value for relative error or relative change, and we know that volume is constant and volume is equal to A into length, area into length. If volume is constant, there will be no change in volume. So we can say delta V by V should be equal to 0. But from this relation, delta V by V will be equal to delta A by A plus delta L by L. So using this, we can say delta A by A is equal to negative of delta L by L. Now in error analysis, we only have we always find maximum error. So we cannot take any value as a negative. So here we will take delta A by A, which is equal to negative of delta L by L as positive. So because we only have to find, always have to find maximum possible error. So in case of errors, every value will we will take as positive. So it will be delta L by L plus delta L by L. So it will becomes twice of delta L by L. Now what we can do? Now we can find out the percentage error. So delta R by R into 100 is equal to twice delta L by L into 100. Now we know that change in L, as mentioned in the question, that change in L is 10%. Change in L is 10%, and what do we mean by 10%? 10% means zero point 0.1. So here delta L by L is equal to 0.1, and I can show you mathematically also. Suppose L is equal to 10 meter, and it is said that the change is 10%. So 10% of 10 is 1. So delta L is 1. So delta L by L will be 1 by 10 or 0.1. So now moving here, putting values. So this will be percentage change in R is equal to twice into percentage change in L. Now delta L by L is equal to 1 by 10 and into 100. So what we will get, that is equal to 20. So there will be 20% change in R. So if initially it was R, now it will become 1 plus 20 by 100 of R, or we can say 1.2 times of R. And that was our answer as comparison to our previous method. So there will be slight change. Here we are getting 1.21, and here using this method we are getting only 1.2, not 1.21. That's why, because in error we do error analysis only when changes are small, when changes are 1%, 2%, or up to 5% only. When changes are of higher order, we do actual calculation, and then we will find the error or change. So that's why there is slight difference, but you can do this question using both of the methods. Moving to the next one, the electric resistance of a certain wire of iron is R if its length and radius are both doubled. So resistance is mentioned, R is equal to rho L by A. That's the original formula. Now length and radius both are doubled. So new resistance will be, as material is same, so rho will stay the same. Length becomes 2L and radius is doubled, so it will becomes pi of 2R square. So it will be rho times 2L pi 4 of pi R square, and pi R square is equal to area. So rho, and this is half. So rho by 2 into length by A, and this is equal to, so we can say it is R naught. So it will be R naught by 2. So our new resistance is half of the original resistance. So the resistance will be held, and the specific resistance or the rho stay unchanged, stay constant. So option B will be the right answer here. Moving to the next one. A 6-volt battery is connected to the terminal of a 3-meter long wire of uniform thickness and resistance of 100 ohm. The difference in the potential difference between 2 points on the wire separated by 50 centimeter will be. So we have a battery of 6 volt and a wire of 3-meter long. 3-meter long wire. Suppose this is our wire, 3-meter long. Between point A and point B. Its thickness is uniform, resistance is 100 ohm. So we have to find out potential difference between 2 points on the wire separated by 50 centimeter. So suppose we take 2 points, point C and point D, and these two are separated by, we can say, 50 centimeter distance, and we have to find out VCD, potential difference between these 2 points. So for that, if we can find out uh, using Ohm's law, we know that V is equal to IR. So VCD should be equal to ICD, current flowing through this CD portion, and resistance of this CD portion. Now current, as this is a series circuit, current in the whole circuit will be same, and current will be total potential by total resistance. Potential is 6 and total resistance is 100 ohm. So it will be 6 by 100 and it will be equal to ICD. Now coming to RCD, resistance of the CD part. Now this whole wire having length of 3 meter has a resistance of 100 ohm. So we can say in 3 meter we have resistance of 100 ohm. Now in 1 meter we will have resistance of 100 by 3 ohm, and we know we have to calculate for 50 centimeter, or we can say half meter, or we can write it like that. In 100 centimeter resistance is 100 by 3 ohm. Now in 1 centimeter, it will be 100 by 3 by 100 ohm, and in 50 centimeter resistance will be 1 by 3 multiply 50, or 50 by 3 ohm. So resistance of this CD part will be 50 by 3 ohm. Now we know the current, that is 6 by 100, and we know the resistance, that is 50 by 3. So 2, and that will be, all will be 1. So option C will be the right answer. Moving to the next one. There are 3 copper wires of length and cross-sectional area L, 2L, L by 2A, half A and 2A, in which cases resistance is minimum. So we have to find out minimum resistance, and for that what we will do? We will calculate resistance for all of these wires individually, and then we will compare them. And as they are made of copper, so their resistivity will be same. So R1 will be rho times L by A. R2 will be rho times 2L by A by 2. So it will be 4 rho L by A. So R2 is greater than R1. And R3 will be rho L by 2 into 2A. So it will be rho L by A into 1 by 4. So we can, from this we can see that R3 is the lowest and R2 is the highest. So wire having cross-sectional area 2A will have minimum resistance. So option B, wire of cross-sectional area 2A, is the right answer. Moving to the next one. If a negligible small current is passed through a wire of length 15 meter, resistance 5 ohm, having uniform cross-section area, coefficient of resistivity of the material is. So we have to find out value of rho, and for that we know that r is equal to rho l by a, and from this rho becomes r times a by l. R is 5, area is 6 into 10 raised to power minus 7, and length is 15. So 3 and 2, 2 into 10 raised to power minus 7. Option B will be the right answer. Moving to the next one. Uniform wire of diameter d carries a current of 100 milliampere. The mean drift velocity of electron of wire is v for the wire of diameter d by 2 of the same material to carry a current of 200 milliampere. Mean drift velocity of the electron in the wire will be. Now here we have to use, you can say, relation between current, drift velocity and area, and that we have that I is equal to NEA VD, where I is current, N is the number of charge carriers per unit volume. So N is the we can say charge carrier density, E is the charge of electron, A is the area, and V is the drift velocity. So we have here diameter, so we will write area in terms of diameter. It will be NE. Area is pi r square and r is d by 2, so pi d square by 4 into drift velocity. Now assuming n and e, pi and 4 as constant, so we can say I is proportional to d square times vt. Now initially we have diameter of d with drift velocity v with current of 100 milliampere. So 100 is proportional to d square into v. Now we have to find out drift velocity for 200 milliampere. So now current is 200 milliampere. Diameter is d by 2. So d by 2 whole square, and drift velocity v dash we have to find out. Now we can divide both of these two equations. What we will get, 100 by 200 is equal to vd square is equal to v dash d square by 4. D square get cancelled. Here we have 1 by 2. This will go on top. We will get 4. So half is equal to 4v by v dash. And from this v dash is equal to 8 of v. Option B will be the right answer. Moving to the next one. Copper wire of length 10 meter and radius 10 raised to power minus 2 by root pi meter has a resistance of 10 ohm. Current density in the wire for an electric field strength of 10 volt per meter is. So here we have to find out current density, and we know current density is given by J, and J is equal to I by A. Now using Ohm's law, we know that V is equal to IR, and from that I is equal to V by R. So J will become V by RA. Now here we have value of resistance. So R is known, radius is known, means area is also known, but potential is not known. Here we have given with electric field strength, note the potential. And from the previous chapters we know that V is equal to ED. V is equal to ED mathematically. So it will be E times, and here distance is length of wire, so L by RA. Using these, we can just substitute all the values. Electric field is 10, length is 10, resistance is 10, and area will be pi times square of this. So 10 raised to power minus 4 pi pi. Pi get cancelled, this 10 get cancelled, and this will go on the top. So 10 raised to power 5, and option D matches here. Moving to the next one, and I think we have to zoom out it slightly. So here we have to match, I think, yes. So here we just written this formula that NEAVD. We wrote in the previous question that I is equal to NEAVD, and from this I by A, current per unit area, is NEVD. This is current density. So here we have D is matched with 2, and here only two options are left when we match D with 2. Now coming to the drift velocity. Drift velocity Vd is given by EE tau by m, and that is option 3. So A is matching with option 3. So A is also matching with option 3 in both A and C. So what is different here? Here we have electrical resistivity and relaxation period. Now, if you don't remember the formula for electrical resistivity, or we can say relaxation period, then there is no problem. But we can simply do error analysis, because we know that relaxation period is time, and for time dimension should be t. First, we will do electrical resistivity. Now, we know that resistance is equal to rho times L by A, and we have to form a formula for electrical resistivity from either option 1 or option 4. So from this, resistivity is equal to R times A by L. Using this formula, resistivity becomes out to be this. Now we know from the Ohm's law that V is equal to IR, and from that R is equal to V by I. So R is equal to V by I into A divided by L. And we know that current by area is current density, that is J, and potential by distance, that is electric field. So it is E by J, that is option 4. So electrical resistivity is option 4. So B will match it to option 4. So hence option A is the right one. Now moving to the next one. Across a metallic conductor of non-uniform cross-sectional area, constant potential difference is applied. The quantity which remain constant along the conductor. So which of the quantity is constant along the conductor? It will be. So let's discuss all the variables, we can say individually. Coming to the current density is J is given by current by area. As we know that area is non-uniform, so area is variable. So J is variable, so it can't be answered. Going to the drift velocity Vd is E tau by m. So it depends upon electric field. So drift velocity will be constant provided electric field remains the constant, and electric field will be variable. Why it will be variable? Because electric field is equal to potentials times distance, and we know that potential depends upon current and resistance, and as area is variable, so resistance is also variable. So electric field is not also constant, and drift velocity will also not be constant. Now coming to the current, that how current will be constant. So In case of a resistance, as this is a metallic conductor, it will have some final value of resistance. So current only depends upon the final value of resistance and does not depend upon how it is changing. So value of current is just V by R, and here R is the total resistance of this non-uniform shaped conductor. It does not matter how this resistance is distributed, that across one end this resistance is larger and across some other end value of resistance is smaller. The value of current only depends on the final value of resistance and final value of potential applied across these two. So hence current here will be constant along the whole conductor. Now with this we end this video here. Hopefully whatever we have covered here till now is helpful to you. Again, if you have any doubts or suggestion, you can put them in comment section. I will try to resolve and answer them. And if you like this video, then do press the like button, share it as much as possible, and subscribe to our channel. Also, if possible, do make some donation by scanning this QR code in front of your screen. It helps us to keep on making these videos on regular basis. So with this, again, thanks for watching, and we will meet in next video.